Okay, so number 4 was the numerical methods-y kind of stuff. Show by means of suitable sketch graphs that the equation has exactly 2 real roots. Okay, well, I can't remember what they gave you in the exam paper for this. I think they just gave you some blank space. They did. They didn't even give you. You know, sometimes they do a space with no lines in it. You just have lines anyway in the exam booklet. So we have to come up with a sketch graph. Well, what have we got? X minus 2 to the 4. Well, x to the 4 is like x squared but steeper. X minus 2 to the 4, we know the transformations we've already talked about today. That means we would shift it 2 units to the right, doesn't it? So that's going to be like, a bit like, an x squared kind of graph, but 2 units across. Let's think about some points where this meets. It's not that big a deal because it's just a sketch graph, but that would be 2, wouldn't it? And if x is equal to 0, 0 minus 2 to the 4, that point is 16. And that's actually quite crucial, isn't it? Because if that point is 16, then the other one, y equals x plus 16, that's gradient 1 passing through the point 16. So the other one, now my sketch graph, I know that's A, not a straight line. In fact, I'm going to do it again because it's rubbish. I'm going to cheat. There we go. This time, and I know that's, you would maybe expect a line with gradient 1 to be steeper than that. But it does hit that line again, and I think maybe this should have been steeper, shouldn't it? You look at that gap there is 2 units, that gap there is 16 units. So my scales are a little bit off, which would make that a little bit flatter than it should be. But there you go, that'll do, I think. That one is y equals x plus 16. That one, the red one, is y equals x minus 2 to the 4. There we go, exactly 2 real roots, and it might be sensible to say, there they are. Okay, and that's it. State the value of the smaller root. Ooh, there it is. And we're focusing, we're not going to make a careless mistake. What would be the careless mistake? Just to go to a careless mistake that people might make is to write 16. It's not 16, is it? The value of the smaller root is x equals 0. Okay? Because it's the value of x that satisfies it. So x equals 0 is the smaller root. Use the iterative formula with a suitable starting value to find the larger root, correct to 3 decimal places. Right, well, with a suitable starting value, that point is 2. That gap is a gap of 2 then. So if I go 2 in this direction now, I'm there somewhere, and it meets higher up. So 4 is probably a starting value that would make sense. You would expect the answer to be a little bit more than 4. I think any starting value bigger than 2 would probably be suitable enough. So what we're doing, part 3, xn plus 1 is 2 plus the 4th root of xn plus 16. And just to do this, I am going to use, x1 is 4, so there's our starting value. I should have set this up already, but I'm going to use my very fancy calculator. Ooh. Oops, it's gone. Check out Dave with his fancy calculator. For more fancy calculator stuff, you could read my blog about fancy calculators.
That blog about it,
Yeah, I haven't updated it since December, but it's it's only got 3 posts in it. It's called Maths Dave's Calculator Riot. You don't believe me, do you? Brilliant. Right, anyway, so in my FX9860G2 emulator, sorry, G2SD, what we would do, remember how to do this, you'd type in 4 and you'd press equals, or execute in that case, and then you'd type in the function, so 2 plus a 4th root, and however your calculator does the 4th root, mine I think will do it really nicely, there we go, the 4th root of xn plus 16, so that is the previous answer, so shift and minus n to get answer, plus 16. Okay, now because we stored 4, our first value is the previous answer, if we press execute, it just gives us the value. And we're looking for it to go to 3 decimal places, so just to make sure, I'm going to write it down to 5 and get it to settle down from there. If we press equals again, it gives us the next iteration. Now we need to make sure we're writing down every single iteration as we go along. That would be 4.11777. Press it again. X4 would be 4.1178. And we place them again here. 5. We want to get it correct to 3 decimal places. It's looking like it's 4.118, isn't it? I might do one more just to check. I'm pretty convinced now. X5 is 4.11785 again, actually. And so at that point, we're pretty much certain. Therefore, X equals 4.118, 3 decimal places. You do all know about this on the calculator. You can do this on either one. It's the way to do it, to make sure. But you should write down the result of every iteration as you go along. And that's maths.